I'm really happy to be here. I've spent many happy hours in this building, some in the chairs you're sitting in, a couple of times before speaking when Terry was running or began this seminar, and many more hours with Manish and many other colleagues and students upstairs. So as Manish said, I'm going to talk a bit about this book I've written. It doesn't capture everything I've done, but the things that I've done about space. It's cheap, and so I never, under $20. So, and I have way too much to tell you, and I'm going to try to tell you too much. So all creatures must move and act in space to survive. So this is a small baby. The baby doesn't yet talk. The baby has learned an enormous amount, and the baby has solved many, many problems without language. And these are great apes, and I could say a similar thing. They don't speak, they gesture a bit, they cry, but language as we know it, they don't have. And yet they solve many intricate problems. They can do rudimentary math. They can tell the difference between 80 things and 85 things without counting. So all creatures must move and act in space in order to survive. And even plants need to be able to move toward the sun, away from the wind, in order to survive. So my thesis, rather audacious in this book, is that all thought begins as spatial thought. What's spatial thought? It's moving and interacting in space with the things in it. So spatial thinking is the foundation of thought, not the entire edifice. I like language. I use it a lot, but the foundation. So some of the argument comes from the recent work that, or the work that it's not, some of it isn't recent, that won the Nobel Prize from the John O'Keefe's laboratory and the Mosers. They hooked up electrodes to rats running around an environment in single cells and found that different places, when the rat was in different places, it ignited specific cells. So one of them is up there. The rat moves here, that cell fires. The rat moves here, another cell fires. They wrote a book, O'Keefe and Nadell, saying this was a cognitive map. The problem was it wasn't a map. Those spatial cells, those place cells, weren't displayed spatially. So the Mosers, working in O'Keefe's lab, both postdocs, found a place where the cells are arrayed spatially in entorhinal cortex, one synapse away. So these were called grid cells. And recent work, and they're created by the movement of the rat. The rat has to be moving. It's keeping track of the movement and the orientation of the head. So they're established by movement. Recent work with human beings implanting single cells in hippocampus and entorhinal cortex, which is done sometimes before epilepsy surgery. So recent work on human beings has found that these single cells in hippocampus fire for events, people, and ideas, not just places. They gather information from all over the cortex, they're multimodal, and encapsulate them in a single cell. What's more, they're arrayed in grid cells. So grid cells array conceptual information, temporal information, and event information. So that makes the case very strongly that spatial thinking is the foundation of all thought. The same brain structures that are representing space, locations in space, are also representing conceptual and temporal and social relations. So the metaphor I use, and I checked this with my hippocampal friends, and nobody screamed, is that the hippocampus creates checkers for ideas or people or events, and the grid cells are like a checkerboard. And they array them in these spatial or conceptual or temporal spaces. What's more, they can be erased. So the grid cells are constantly being rewritten as information. They're active. Okay, so the spaces, the book, this is the cover. I didn't design the cover, but I'm fond of the design, partly because some people see a man running, and some people see a network. And it's meant to be both, so it's a little bit, do you see the forest or the trees? And these are some of the topics that I cover. I talk about, and I'll give you capsules of these. The spaces we act in, I just gave you brain. Abilities, I won't give you. Perspective is key. Gesture, language, cognitive tools, creativity, the design of the world. So before I get into tiny tidbits of each of these, I want to show you some people thinking. You're going to get to watch thought in action. So we bring people into the laboratory. We close the door, so they're alone. They're going to be reading a description of space. It's a complicated description locating 8 or 4 landmarks in a spatial array. It's hard. And they're going to be tested, okay? So they study very hard. These are students, they know how to study. So this is a bit of one of them. Etna is a charming town nestled in an attractive valley entered on River Highway. River Highway runs east-west at the southern border of the town of Etna. Toward the eastern border, River Highway intersects with Mountain Road, which runs north of it. So you get the idea, and you won't be tested. So here is one woman, and so watch her. She's reading that description, and watch her hands. She's not watching her hands. So I think you can see she's making a map, right? She's making lines for the paths, and she's poking dots for the places. And 75% of our participants do this. And when they do it, they remember better. They perform better on the test. And if we tell them to sit, I'm sorry?
Next.
Oh, no. They aren't primed at all to do it. We don't tell them. In fact, if you tell people to gesture, it's mixed. So as I said, 75% of the people do it. When they do better on the task. And if we tell them to sit on their hands, they do worse. And some of them say, I can't think without my hands. So I'm going to continue in this one. I'll show you one more. We've by now done this with all kinds of stimuli. It works best with spatial environments and with mechanical systems. You had a question.
Do you see what fraction of people talk to themselves?
Sometimes people talk to themselves, sometimes not. It really varies. And there are people that don't gesture and do fine. But, you know, anytime you study people, you get variability, you can't, right? People do the strangest things. So this person is reading a description of how a car brake works. It's again hard. They get to read it 4 times. So from the brake fluid reservoir, brake fluid enters and travels sideways and down the tube. As the brake fluid accumulates at the bottom of the tube, pressure is exerted on the small pistons inside the wheel cylinders. This causes the pistons to move outward toward the brake drum. It's hard for me to read it without gesturing. So we'll watch him and hope he comes up. He's just great. Yeah, he's a dancer. So you can watch him. He's trying to figure out the car brake, and you can see him kind of reading, testing, reading, testing. I mean, as I say, you're watching someone think. That's not a gesture. Okay, so you got it, okay? And now I'll go back to the other. So the gestures model the situation described in the text. And the models are spatial motor. They aren't visual. They aren't looking at their hands. Preventing the gesture reduces comprehension. And we get the feeling watching them that the gestures are translating the language into thought by creating a model. The language itself is arbitrary. If that were in Chinese, it would look very different. We've also looked at gestures for others. I'll tell you one study of many. Students watched an explanation of how a car engine works, and half of them watched one video, half the other. One video used gestures that showed structure, the shapes of the parts. We didn't think that would have an effect because that kind of information is easy. The other one showed action. And action is really hard for people to get, and that's a longer story. Again, they were tested. They could see these videos 4 times. They were tested, true-false questions on structure and action. They made a videoed explanation of the engine, and they also made a visual explanation of the engine. So what we found was the people who watched action gestures got more action questions correct. But what was more striking to us is they really incorporated the action just from seeing the gestures. The text was the same, but just from the gestures, there was more action in their visual explanations. There were more action gestures. The gestures were invented. They weren't the ones they saw, for the most part. And they used more action words, even though they hadn't seen more action, heard more action words. So this is a visual explanation from someone who saw structural gestures. Again, same text. Another one. This is someone who saw action gestures. And you see much more action there. There are arrows. We counted arrows, many more arrows. You have that explosion there, and you have bubbles there. So there were many more depictions of action just from seeing the gesture. So seeing those action gestures made them understand the action in a much deeper way. Here's another one. They also got the stages more clearly because the stages are distinguished by actions. So gestures and graphics. Gestures both are a more direct expression of thought than language, which is pretty arbitrary. Gestures are actions, so they're especially good for actions. However, they're fleeting. Graphics are static, and they stay around for you to think about and inspect and maybe change. So gestures are for here and now. And as I said, there are great apes that use gestures, mostly for sex. But they use them. Okay, graphics are for other eyes and other times. So they're, in some sense, the first solid evidence for symbolic thinking in people. We don't know when language evolved, but we can see when people started putting their mind in the world. I'll get to that in a second. I'm already going to see that I'm going to have to skip stuff. Okay, so space is special. It's supramodal. It's kind of the confluence of vision, but blind people can have really good spatial cognition. So you get it from hearing, from smell, from kinesthetic, where there's wind, what the pavement feels like. All of these are cues that blind people use, but it's the confluence of many senses. It's essential for survival. If we didn't know how to get home or get food in our mouths, we'd be dependent on people forever. It's the basis for other knowledge you've already seen. It's not like geometry or physical measurement. Our mental representations of the spaces that we act in are distorted, and they're distorted by our action and our perception. We live in many spaces, and we create many spaces by our actions and for them. So the space of the body, I'm going really fast over. The space of the body, here function or action trumps size. So our representations of bodies, you can see from children's drawings, they're the same all over the world, big heads, big hands. And the brain exaggerates the places in our bodies that are important for our action and shrinks the ones that are less important. So the space of the body is distorted in that way around our actions. The space around the body, here we've looked at what kinds of reference frames people use to understand the world around them, and they use their own body axes and gravity. And again, gravity affects our actions enormously and the way things work. The body axes are by the asymmetry. Head, feet is more essential for keeping things in mind than left, right, head, feet, and front, back. So it's again a longer story. Space of exploration. A remarkable feat of the human mind, and also we saw of the rat's mind, is to experience a world from exploration and create a map of it. That's as if from an overview. So we experience the world as we see it and move through it, but we are able to create a mental representation of a larger space, one that we can't see from one place, in our minds. So this strikes me as a remarkable feat of human being. And we talk about the embedded route, the one where we're walking through it as a route, and the overview as a survey. And human beings can switch back and forth, something we've studied and others. And when we talk, we tend to mix those perspectives. So perspective is a key issue. It's a spatial concept. It's a key issue everywhere. And one part of it is whether we're seeing the world from our point of view, egocentric or allocentric from above, but another is whose perspective are we taking, mine or yours? And some work with Bridget Martin Hard showed that when, this is her husband, Patrick, and when action is involved, we automatically take the perspective of the other, or we're more likely to take the perspective of the other than our own. So if we tell people, where is the bottle? Where did Patrick put the book with respect to the bottle? And I'm standing next to you asking that question. So from our point of view, the bottle is on the left, but people answer from Patrick's point of view and say on the right. And if we make them take their own point of view, it takes them longer. So when we see action, we're inclined to take the perspective of the actor, perhaps to understand the action, perhaps to prepare our own. Is he going to throw the book at us, or is he going to give it to us? We have to prepare our own. So perspective taking turns out to underlie, and I'm not going to be able to go through this, it underlies empathy, certainly, problem solving, prediction, and creativity. We found that when we ask people to think of new uses for old objects, a common creativity task, they're really good at it when we ask them to adopt different roles of different people. The space of exploration is full of distortions, and we group things hierarchically. We use landmarks as landmarks, and things get drawn into landmarks, so people think that Jacques' house is closer to the Eiffel Tower than the Eiffel Tower to Jacques' house. Perspective I just told you about. There are a whole range of ways that we construct the space that we explore, and it's full of distortions. So we liken that to a collage. It's not coherent in 2 dimensions or even 3, not a mental map. And each of these distortions of space has a parallel distortion in social judgments, in temporal judgments, in conceptual judgments, something I won't be able to go through, suggesting that maybe all judgments are cognitive collages. We just gather information from all over. How we gather it depends, and we try to make something coherent or something reasonable from this collage of information. social spaces. So anyone who's observant about ourselves and about babies can't help but notice that we spend an enormous amount of time playing games that don't involve language, that are social games, from rolling a ball with a baby back and forth, teaching turn-taking and trust, to basketball, which is incredibly complicated. And we're doing those actions, or the good players, in split seconds. So why are we spending so much time playing these social interaction games that don't involve language? Even Scrabble, it's about words, but the way we communicate is by making a word. We don't say. So okay. So then there are the spaces we create in the mind, in gesture, on a page, in the world, in words, on the page. So a bit on language. Our minds go from thought to thought the way our feet go from place to place. We saw that in the place in the grid cells. And we talk about actions on thought in the ways that we talk about, in the ways that our hands act on objects. So splitting hands and feet. We raise ideas, pull them together, tear them apart, turn them upside down, push them forward, toss them out. Now, Lakoff and Johnson presented these as metaphors, but I don't know if there's metaphors. We have no other way of talking about actions on thought except these ways. So I think we internalize the actions and then use them on these thoughts that we objectify or reify. There are metaphoric uses all over the place. We talk about being out of depth, the top of the class, feeling up, falling into a depression. These are all, they're all communicated with gesture too. We've grown closer, grown far apart. So those actions on objects get turned into gestures on thought. We put the world in the mind. I just talked about that. Now I'm going to talk a little bit about putting the mind into the world. And we do that to enhance our physical lives, but I'm going to talk about the ways we put thought in the world to enhance our cognitive lives. Our cognitive tools can inform and educate. They can augment memory and information processing by offloading it to something out there. They use space to represent literal and metaphoric space in action. They promote inference and discovery because I can look at the page and think about it. I don't have to keep the page in mind and think. They're public, so they allow creation, revision, and inference by a community. And I put forth they're uniquely human. Nobody's seen a great ape make a map in the sand. Now, I'm open to other examples. I'd be very interested. And as I said, they're the earliest evidence of symbolic thought. So let's look now at some of the ways that people put thought in the world. This is the former oldest map, and if you still look at websites, you're going to get this one. Note that there are two perspectives. It's a big stone, that's why it survived, from Babylonia. And it's representing the overview of the paths and frontal views of the landmarks. So it's mixing perspectives, which is extremely common, even though the linguists and the geographers say we shouldn't be, and the psychologists, we shouldn't be doing that. This is the current oldest map. It's about 2 inches by 1 inch, so it's very small. It would fit in your pocket. It was found not long ago in a cave in Spain, so it's very enlarged. It goes back 13,000 years. It again shows the paths and the landmarks at the same time, and it depicts the scene outside the cave. So can you imagine being an archaeologist walking in this cave, picking up this small stone and seeing it's a map of the place we're in, and how exciting that would be. So space, we also show this. There are also ancient examples of the space of the skies. This one is actually showing, it's going back, 5,000 years, and it's showing an asteroid entering the skies. It's something we wouldn't notice without a telescope anymore because we can't see stars anymore. These are Eskimo coastal maps. They're small, they fit in a mitten, and they show the outline of the coast. These are for canoeists that go up and down the coast, so they can be explored with their hand instead of their eyes. And if they fall out of the boat, they float. More floating maps. This is South Sea Islanders. The bamboo strips are the ocean currents. The shells are the islands. They can't be seen one from another. But people learned how to navigate with these, also using stars and flotsam and jetsam on the ocean, and at least some of them got back. Okay, more maps, hands. This was used by North Coast Indians to show the major cities. Anyone from Michigan holds up a hand and to show where they live. This is a New Yorker example. Okay, so we have space of the world around us, of the stars, time events. This is Chauvet, and it's showing animals. It's people, not here, but in others. And this is probably a stampede that it's showing. This is what's called newspaper rockets somewhere in Utah, a whole set of petroglyphs. And again, showing a hunting scene. You can see stick figures with their bows and arrows and the animals they're hunting. This is another celestial event. It is a petroglyph. Here's the petroglyph. Here's a drawing of it. It was found in Kashmir. And an Indian astronomer it was dated recently, and an Indian astronomer showed, so why are there two suns? The Indian astronomer showed that there was a supernova on that day or on that date, and it was a striking enough event that somebody took the trouble of carving it into a petroglyph and keeping it there for the future. So we have events, people, objects, things. This is how to make bread. It's in an Egyptian tomb. You wonder what it's doing there. Time, calendars from many different cultures. Some are circular. That's a story I could tell. Some are more linear, like the calendars that we use. Tallies, one-to-one correspondences, so rudimentary math. More sophisticated counting. Some people used more than their 10 fingers to count. They were much cleverer than we. Peruvian quipu for counting, abacus. So ancient graphics show people, animals, things, place and space, time and events, and number. Again, this rudimentary number, one-to-one correspondences. Modern graphics show the same things. And these are things that must be important to people. And in fact, the brain takes special note of them. Okay, so that's ancient depictions, ancient ways of putting things, our mind into the world. I'm going to show you some more contemporary ones. More or less, modern graphics sort of began with the Enlightenment. And Diderot was one of the first. Diderot had an encyclopedia of all things, including the mind. He has the beginning has a network of faculties of the mind, an early cognitive scientist. So here he's teaching people what a diagram is. People would have seen depictions of scenes, like at the top. That's a factory making pins. That would be familiar to people. The diagrammatic part wouldn't be. So he's got the top part in a box, the bottom part in a box, separating them. The bottom part is a catalog of the instruments used above. It's something familiar to us, but the sizes don't correspond to the sizes of the actual sizes. The sizes are distorted so you can see them. The lighting, you can see at the top, is normal lighting. They all have that kind of lighting, just the way Vermeer used one window with lighting. And the shadows and the lighting is the way natural light would fall, or the way the etcher thought natural light would fall. The lighting here is to accentuate the three-dimensionality. So it's using the features that we normally associate with scenes. It's using them in different ways in order to communicate better. So things are lined up in rows and columns, not the way they're used, right? So this is an early diagram that's teaching what a diagram is. This is an 18th century graph, and it's showing balance of payment. It's plotting balance of payment over time. And somebody looked at all the graphs, this is already 20 years old, in both scientific journals and places like The Economist and USA Today, and found that 75% of them are plotting one or two variables against time, which is, again, the early uses of it. So I'm going to skip that because you've seen it. This is work with Manish. Other ways that diagrams are used, visual instructions to show you how to put a TV cart together. This is what our high spatials produced, and this is what Manish and his team turned into an algorithm where it's using the cognitive design principles that we uncovered through the psychological research and the design principles show each step, and each new part is a new step. Show the perspective of action, and embellish with guidelines and arrows. And this could be an explanation for a car engine. You'd want to follow the same principles. Other ways of using graphics, comics, I'm a big fan of comics. Not so much the subject matter as the way they use the visuals. So this is using space and time together. And that's something quite common. You have the time in the windows going left to right and top to bottom, and superimposed on the space. There's a map in the Mayan codices that did something similar, so it's a natural way to think. Larry Gonig drawing spatial analogies to tell you about acceleration. Harold in the Purple Crayon drawing his own story, for those of you who know the book. And Steinberg, again, using sort of metaphoric or humorous ways of using space. So good graphics schematize. How are we doing on time? They eliminate the irrelevant and exaggerate the essential. They show multiple perspectives. The London Tube map does not, but you saw plenty of examples that do. And they're multimodal. They have symbols and language in addition to the visuals. They use spatial relations and marks and elements in ways that convey meaning directly, again, in contrast to language. So proximity in space signifies proximity on an abstract dimension. We've grown closer or grown apart. Centrality is centrality. And directionality, the vertical is loaded, again, because of gravity. So it takes power and resources and health to go up. So just about everything good goes up. Horizontal seems to be more or less arbitrary. There's nothing in the world that captures that. But our cultural artifacts or our cultural customs do. So reading and writing order, and also order of math, and they don't always agree. And again, there are parallels in language and gesture. I'm going to gesture events in time along a horizontal line from my left to right. I just did it the opposite for you. So centrality, we ask people to make their social networks, and of course they're in the middle. Gravity, we looked at diagrams for evolution and geological ages in all the introductory texts we could find in the library. And the present time, man, it's always man, is always at the top, because that's the best. Okay. So horizontal use of space, writing order correlates with the number line, with agency and power. I'll give you some examples. With speed, with aesthetics, and value seems to go with handedness. It's the only thing that goes with handedness. And it also goes with reading order. So power, we have Adam on the left and Eve on the right. This is quite common in pictures. And in fact, there's some, I saw an exhibit at the British Museum once of art in India. And when the language shifted from left to right to right to left, the painting shifted. Okay, all of a sudden the Maharaja is not running from left to right, he's running from right to left with his harem chasing after him. But it shifts when the language direction shifts. So this is soccer goals. We see motion going in reading order as more forceful, violent, and beautiful. And in fact, more fouls are called when from the referee's point of view, the ball is going opposite reading order. So nobody's tested that yet in Israel or one of the Arab countries. They need to. So the butt of jokes, nothing is left, nothing is right. Elements. So we can have elements that we talked about the meaningful use of space, now the meaningful use of elements, and I'm going to argue that they communicate quite directly. They can be iconic, so they look like what they're representing, metaphoric, like scales of justice, and meaningful marks, which is what I'll dwell on, and symbolic. So symbolic, we have, or the meaningful marks, we have dots. I don't know why that one got truncated. We have dots indicate places or ideas, as they do in the brain. And lines indicate paths between ideas, so relations. Arrows are asymmetric relations. And containers can either be something like a set or an area, or a box, as Diderot used it. And I'm not going to be able to talk about all of these, but there are shared meanings that for these, for dots and lines and boxes and arrows. And we looked at that in a variety of experiments, looked at the shared meanings by presenting the visuals and asking people to interpret them, or by presenting something in language and asking people to construct a visual. And when you get the same thing, you can say the meaning is shared. So we looked at, with Jeff Sachs, we looked at inferences from graphs. We gave people one of those graphs, either A, B, or we labeled them with the height of kids 8 and 12 or height of men and women. So they only saw one and they were asked to interpret it. And our idea was that bars separate, they contain and separate. So they say there are more Bs than As, or Bs are greater than As. But they don't imply a relationship. A line implies a relationship. So it says A and B share a value. They share a dimension. They just have different values on the same dimension. And so we expected people to give us discrete comparisons here and trends with the lines. And that's, in fact, what happened. And if we describe trends and ask people to create a visual, we get lines. If we describe discrete comparisons and ask people to create a visual, we get bars. I'm going to skip root maps, but you can see that there are lines and dots, and the visual elements tend to be these sorts of visual elements in the sketch maps that people produce, and they map onto language. So the root maps aren't analog, even though they could be. They're distorted in much the way language is. So just as we say turna teka, the angle of a turn aren't specified, and they're often not right. And the curvature is either straight or curved. It's discrete. So you either go down a straight path or you go around when it's curved. So we found that these descriptive and depictive elements are parallel, suggesting the same underlying representation. And when you think about it, the brain doesn't have words, doesn't have propositions, doesn't have images. It has neurons and glia and all kinds of other things that are affecting our thinking. So the representation that generates either pictures or language seems to be the same. So I showed you that, or you saw that these schematic maps, this is how to get to Taco Bell from one of the dorms. And it's making right angles where there are none. The distances are way off. So why do they work? They work because of context. Language, too, works in a context. We have a mutual understanding for interpreting our language, and a sketch map is also going to work in a context. And if I come to a fork in the road, and I think it's a right angle, but it's not, I'm not going to make a right angle with my car, I'm going to drive along the road. So, and we have, again, similar understandings. So this yielded cognitive design principles, and again, Manish and Chris Stolte took over that paths and nodes are important, but distances and exact directions aren't. So instead of, this is years ago, none of you remember this, or only some of you. These are the maps you used to get from websites, and they don't tell you how to get on and off the highway. The information you need isn't there. It's cluttered by all kinds of irrelevant information, and these are the first pass of the maps that Manish and Chris produced, and they were loved for good reason. And it just shows you what I love about engineers. You know, we do research. Engineers gather, distill information from so many different places and produce a tool that we can use. Okay, we get similar things in gesture, pointing to landmarks, tracing paths, endings. What's interesting about gesture is they make a narrative about it. It's got a beginning, middle, and end. Arrows, and then I'm going to really jump. So arrows are interesting. Partly they don't seem to appear before the 20th century, and I'd be eager for someone to find examples, early examples of arrows. You do have hands and fingers and even feet. There's a lovely petroglyph in Ephesus with feet telling you how to get to the brothel. It's bringing you there. So there are the arrow-like things, but arrows per se, I don't think anyone's found one before the 20th century. So they have a sort of natural interpretation in that the erosion lines look arrow-like, and of course arrows that fly. But they have many uses. So this is work with Julie Heiser. We gave people one of these drawings, one of these diagrams, either with or without arrows, and asked them, tell me what it's conveying. And we found that without arrows, we got structural descriptions. People told us where the parts were in relation to each other. So you could tell it by the language. They were isas or hasas. And with arrows, we suddenly got step by step, beginning to end, functional action descriptions. And again, active verbs. So it was unambiguous how we coded them. The arrows changed the meaning. Then we gave another group of people either a structural description or an action description and asked them to produce a diagram. And again, this is very typical. So they drew these diagrams just from the descriptions. It's pretty good. But you can see from a structural description, they label the parts. When we gave them an action functional description, they don't label the parts, even though they were labeled in the description, but they give us arrows indicating the action. So arrows convey meaning. They change something from structure to action. The trouble with arrows is that they have many meanings. Bob Horn, whom you may know because he spoke here many years ago, and is very interested in visual language, he came up with 107. That seems too many. So, but you can get 7 or 8. They can point, connect, they can indicate the temporal next step, they can indicate causality, they can show movement, direction, manner of movement, wavy arrows, staccato arrows. They can indicate increases, decreases, they can indicate invisible forces. So these were very common in World War II, and the arrows are being used, they're color-coded by the side of the war, and the width is indicating the number of troops, and the direction is where the troops are moving. These are pretty standard and comprehensible. We looked at the diagrams in STEM books. I have those diagrams if somebody wants them. We analyzed what kinds of diagrams are used in STEM books. So this one is is foreign DNA entering cells. It uses arrows in 3 different meanings without disambiguating. So this is hard for students. I mean, I could figure it out. I'm no expert in this, but there are cases where, so these are labeling transient open foreign DNA. The foreign DNA is entering, that's movement. This arrow is the next step, so it's being used to label, indicate movement, and the next temporal step without really disambiguating. Again, the context was sufficient for me to figure it out. I worry about other people. And then you get beautiful things like the rock cycle. And the geologist will say, what's the problem? And then I say, what does this arrow mean? What does that arrow mean? And they say, oops. So even they can't interpret it. And I have plenty of examples of them where they're beautiful, but in even abstract ones, the arrows aren't disambiguated. Here, if you've been to Venice, you know you encounter this kind of situation very frequently where the arrows point in both directions. This is how to pass a bill in Congress, right? You go in circles. Okay, so these schematic elements are like schematic spatial terms. Point is a place or an idea, line is a path or a relation, an arrow. And like spatial terms, so it becomes a visual vocabulary for diagrams. You can create diagrams out of these and adding the iconic ones. And again, they're schematic and the context is going to disambiguate. Is it a romantic relationship or a mathematical relationship? Again, the context presumably will tell me. So Steinberg got there first. Lines have many meanings. This is wall-sized, and there's Steinberg drawing, and it's the Grand Canal and a clothesline, and the sidewalk from above, and the Nile, and the top of a railroad bridge, and so on. But you're not even aware that it's the same line because you quickly interpret it. So neat lines are great for getting you from A to B or telling you how a car brake works. But then there are messy lines. And this is Gary, and this is a drawing that he made. And we started studying messy lines. This is work with Masaki Suwa. We looked at architects, and we gave them an assignment to make a museum with certain constraints. And they make discoveries in their sketches. And it's exactly the ambiguity that allows them to reconfigure and make new discoveries. Artists do the same. This is a graduate student, a former graduate student, fine artist, who studied artists. And they can't talk while they're drawing. Same with the architects. Language interferes. It's a conversation between the eye and the hand and the page. And artists say the ideas emerge from the page. So I'm going to skip here. This is using diagrams for inference. We've shown that diagrams promote collaboration, and now I'm going to try to end. So this is the world that nature gives us. It's pretty messy, and in fact, messy desks promote new ideas. This is the world we design. So how do we design the world? We put the mind into the world. One prominent way we organize our lives is around themes. We put all the things that belong for cleaning in the bathroom, all the things that belong for cooking in the kitchen, and so forth. So we gather many different kinds of things, put them in the same place because they're going to be used together. I call them themes. We also have categories of things, and our categories go on shelves. So we put our plates, small plates here, our bowls here, our cups there. And again, we're organizing them into categories and hierarchies of categories in our homes and in the supermarket. And on our bookshelves, orders. Our books might be ordered by topic, they might be ordered by size, but we get orders in there. So again, this is a fruit and vegetable stand, categories, hierarchies, lines, boxes. The world is organized that way. Lines and rows and columns and boxes in 3D. Assembly lines. One-to-one correspondences is beginning to sound like programming. one-to-one correspondences, repetitions, cycles, embeddings in our place settings. And kids grow up with this. There's so much intelligence around us. The caves didn't have so much. Similarly here, repetitions, symmetry, embedding. We use those patterns, which catch the eye because they're good gestalts. We use those patterns deliberately in our visualizations. So the periodic table, train schedules, bar charts. This is the likelihood of a computer issue being solved by reconfiguring, re-imaging, antivirus, uninstalling other, or turning it on and off. Okay, and this is the amount of time it took me to draw each bar. So I introduced the concept of spraction. It's a contraction, and it's an ugly word. All Latinate words are ugly. It's a contraction of space, action, and abstraction. And the idea is actions in space create abstractions. You just saw a bunch of them. Those actions get internalized and re-externalized as gestures, as actions on thought. And the patterns get used and externalized as communications, as diagrams. So this is spraction. It's a kind of cycle. We can enter at any point, linking space, action, abstraction. So we not only put our minds in the world, we design the world. And we saw that, but we not only design the world, we diagram the world. So the world is a diagram. And with that, I end. And so that's just thanking the funders. So we're probably out of time. I don't know.
We've time for a couple questions.
I know I've overwhelmed you. It's too much to take in. Yeah.
So my research area is NLP, and I think a lot of people talk about your work as saying it's action that really matters, not language. But what I'm hearing here is a bit more, I don't know, more nuanced. And
Thank you.
I'm curious, if you could talk a bit about the cases where each sort of is important. So in the case of like Nicaraguan Sign Language, for example, you had a bunch of deaf children who were brought into a school and they invented their own language. At the beginning, it was very filled with gestures and actions and movements. But in the next generations, it became much more symbolic, much more like language and less like action. So,
right, and this, so thank you for the question, which also informs people of the transition from gestural sort of language to one that has a real syntax and semantics. So again, I'm fond of language. To differentiate, differentiate what graphics do and what the annotation of graphics do, it becomes difficult and it's overlapping. Clearly, deaf people manage perfectly well without hearing, or can manage, and blind people can manage quite well without seeing, although blind people gesture. And blind children gesture, again indicating it's for their own thought. And I think they're complementing each other. And there are many cases where the gestures are really giving you more information than the language. So if you ask someone where to go, so I was once trying to find a store in London, and I knew you had to make 2 turns from where we were to get there. And I asked a woman in a store, and she said, you go straight on, straight on, straight on. And I said, don't you have to turn? And she said, yes. But, her head is always pointing forward. So, and she doesn't know the name of the street. So for her, it's straight on, straight on. And if you get lost in a foreign country and ask, and you know 4 words of Italian and not more, you watch the gesture. And the gesture will tell you, is the road curving? Is it going up and down? So and that's our canonical way of speaking, is language grew up, you and I talking, or groups talking, and it was multimodal. It used the intonation of our voice, which can negate what we're saying by irony. So human beings are remarkable in being able to use all kinds of resources to make meaning, and some of it is we've had experience undoubtedly making meaning in those different ways. So we can understand things from writing, but we all know that emails get misinterpreted and in many ways, and that watching someone's face and seeing their gesture and hearing their intonation will change it. So you lose something. And it's similar again in space. Blind people manage without seeing. So some things are complementing. So I'm not answering your question exactly. One thing that I think gestures do really nicely that language often forgets to do is they set up a general schema for understanding things. So a simple example is on the one hand and on the other. And then I can keep referring to those places in space. I've set them up, and I can keep referring to them, and I can even create a middle space. And I'm often doing that without saying. And you're seeing that and getting it from the seeing. So there are many studies showing that if you take away the gestures from an oral communication like this, you lose a lot. If you take away the language, you're going to use a lot too. So that's not a direct answer, but maybe some of the nuances you were looking for.
Maybe one more question for now.
Pardon me?
One more question.
Okay. And I don't hear or see, so I'm coming back to hear you.
Yes. Do you think that abstractions or the way we interpret diagrams and graphs are universal, or do they vary across cultures? And are they innate, or is it because of our Western education that when we see an arrow, we think, oh yeah, this must mean force or things like that?
And those are good questions. And the answer always with cultural things is yes and no. Or with education, yes and no. Is somebody went, this is just an example, somebody went to, and again, gestures and diagrams have similar visual vocabularies. I hope that was clear. Somebody went to New Guinea years ago, this is probably 40 years ago, and they're river traders that go up and down the river. They're not literate. And they're trading, and they've never seen a map, they've never been in a schoolroom, and asked them to make a map. And it's a small sample, so these aren't real data, they're anecdotes, but what they drew was a line with circles where they stopped. So that idea that the rivers, they regularized to a line, it's not a line, and that the stops were these dots, was their way of expressing. So there's going to be some universality, there's going to be some cultural specificity on either diagrams or, and those are harder and harder to study because, right. Okay, I think you want to end at this point, right?
Should be here for a couple minutes if you want to come up after.
Yeah, right.
Let's thank our speaker.